So a spinal cord injury could happen to any one of us at any time. In an instant, your whole life could be changed and you could lose all your feeling and control of function below the level of the injury. They usually happen as a result of a road traffic accident or a fall or sporting injury. Here at King's College London, we're studying regenerative therapies to try and repair the tissue, to get some tissue repair and restore some function after a spinal cord injury. So this could be functions such as hand and finger function and limb movements and coordination and balance and movement. Here you can see a cross-section of an intact, uninjured spinal cord, and you can see the nerve cells here in green and supporting cells in red. This is what happens to the tissue after a spinal cord injury. So you've got holes in the center of the spinal cord and you've got this thick scar tissue, and things don't repair and regenerate. So what we're interested in is trying to maximize the function of this remaining tissue, because in nearly all cases there's some tissue remaining after a spinal cord injury, and there is some capacity for the central nervous system to repair itself. What we want to do is find out what are the molecular signals that underlie this spontaneous capacity for repair, and then we can try and target these with future therapies. We use mice that lack the Neuregulin-1 gene, and what you can see in these mice, so this is a normal mouse that has Neuregulin-1, you can see there is some capacity for spontaneous remyelination. But in mice that don't have the Neuregulin-1 gene, they remain severely demyelinated. And this also impairs their recovery of function. So mice that lack the Neuregulin gene are very much more impaired in their walking ability and in their balance and coordination. Really interestingly, what we found was the cells, Neuregulin-1 controls this spontaneous remyelination. So these green rings show newly generated myelin right in the center of the injured spinal cord. And this has been generated or produced by these red cells here. And the reason these are red, this shows that they're newly dividing cells. So these have come up naturally after a spinal cord injury. They're producing myelin, which ensheathes the central axons in the spinal cord and improves their conduction and function after a spinal cord injury. We can then zoom in even further on these cells, 8,000 times, and you can see here one individual cell which is producing this myelin, which is surrounding the spinal axon. And here you can see one spinal axon with a thick myelin sheath, which is being produced by these Schwann cells. And these are normally never present within the CNS, but we see these after a spinal cord injury. And we now know that the signal that controls this myelination, this natural spontaneous remyelination after spinal cord injury, the signal is Neuregulin-1.
Not only is neuregulin important during the development of the peripheral nervous system, but it's been known now for a number of years that it's also key in repair processes. And remyelination after peripheral nerve injury is dependent on neuregulin being expressed by axons. It's quite a complex system to study, and that's because Neuregulin-1 is not just one molecule, but actually exists in many different isoforms. There are some isoforms that will remain tethered to the axonal membrane. They're called the type 3 or cysteine-rich domain containing neuregulin isoforms. And there are some isoforms that after proteolytic cleavage will be released into the extracellular fluid and act in a paracrine manner. Now really, I started to move into the central nervous system very much as a collaboration with Elizabeth Bradbury. And that was because of this observation that after spinal cord injury, Schwann cells were observed remyelinating axons following spinal cord injury. And we wanted to ask the question, is it after spinal cord injury that neuregulin may in fact be controlling that remyelination process, and maybe it has a role in repair processes following spinal cord injury? And that's really how this work evolved.
What we want to do now in the future is to try and control this Neuregulin-1 signaling and improve the signaling so we can improve and maximize function after a spinal cord injury.